Good morning, this is Phil Thomas from New Era Systems. If you've seen any of my previous videos, particularly when I'm testing an amplifier, you'll see two common components. One is a cross-guide coupler, the other is a dummy load. So I'd like to start off discussing the use of those two, why we use them. I'm going to begin with the dummy load. On the cart in front of you, I've got several different types of dummy load. So the first question is, what is a dummy load and why do we use it? Testing radio frequency amplifiers, we are typically working at 6 gigahertz or 14 gigahertz. These are microwaves. And when you think of cooking in a microwave oven, you're using approximately 2.4 gigahertz. So you can think of an amplifier as really a microwave oven on steroids. You would not want to put your hand or any part of your body in front of the output of an amplifier. Normally what happens is that the output from an amplifier goes through waveguide, it goes to the port on an antenna and up into 22,000 miles of space to hit the satellite. Well, it's not always convenient when we're testing to put up an antenna, and so we use these dummy loads to absorb the radiation. What they do, they take the radiation and they convert it into heat, which is why these dummy loads have all of these fins. These are cooling fins. More fins, the more surface area, the greater capacity they can handle. These two are high capacity, 1 to 2 kilowatts. The one on the left with the bigger flange is for C-band. That's called a WR137 flange. The one on the right is KU band, WR75. And as I said, these are both high capacity dummy loads. This is a smaller capacity dummy load, also KU band. This will handle up to 500 watts, which seems quite remarkable when you consider its small size, but that's the manufacturer's specification. Finally, we're going to look at an even smaller one. This will only handle 25 watts, which in many circumstances is perfect. This 500 watt dummy load is already connected to a cross-guide coupler. So now let's look in more detail at what a cross-guide coupler is and what does it do. I'm not really good at explaining electronics, and I always look for an example in the physical world. I think of a cross-guide coupler as something like a tap that's set into a high pressure container. By connecting a dial to that tap, you can measure the pressure in the container. The cross-guide coupler is somewhat similar. It lets us measure the output power of an amplifier. To make this measurement, we connect the coupler to the output of an amplifier and connect a power meter to the coupler's monitor port. Normally, when an amplifier is transmitting, the power flows through the cross-guide coupler to the antenna feed, but we don't set up an antenna for our tests. Instead, we connect the output of the cross-guide coupler to a dummy load. Cross-guide couplers are calibrated to work in a set frequency range. If they're KU band, then the range can be 13.75 to 14.5, but there are other couplers that are calibrated for C band and almost certainly for KA and a whole range of other frequencies that may be necessary. So of course the advice is, if you know you're going to test an amplifier in the 13.75 to 14.5 range, make sure the coupler covers that frequency. Now here's a few that we've got in stock. The one on the right, the red one, is typically C-band. It's got a WR137 flange and it's got 2 output ports. The center one is KU band, and again we keep these on the shelf all the time. We use these very frequently for testing. And the other two on the left, the white one is WR137, again it's a C-band, and the one closest is also C-band, but it's for the input side, so it's a 159 and not a 137 flange on it. To get the reading, we test the output port to this power meter. It's an Agilent E4418B, and it's our favorite power meter. However, there's a problem. The power head will only read up to about 20 dB, and 20 dB is a fraction of 1 watt. So how am I going to test a 200 watt, 400 watt, or even 700 watt amplifier using this power meter? Well, the answer is on the coupler itself. The coupler has attenuation factors built into it. You can see a frequency range starting on the left hand side top row. The frequency is 5.925 and the offset or attenuation is 30.2. Slight difference as you go up to the top end of the frequency range, which is 6.425, top of the standard C-band frequency range, and now the offset or attenuation is 30.3 dBm. Now another interesting thing to notice is these arrows. It shows us that the input power comes in through here and it comes out to this monitor port here. This cross-guide coupler again is KU band. It's interesting in that it's got 3 ports. If you look at this, where again it's about 13.75 to 14.5, which is the full frequency range for KU band, you can see at 14.5 it's got an attenuation of 36.5. But if you come down to this port, it's got an attenuation of 53. And this is important because if we're testing a low power amplifier, we would probably use this SMA port. If we're going for a much higher power amplifier, we're going to go with this one because it's got an offset of 53 dBm, allowing us to test at a much higher rate without damaging the power head of the power meter. Okay, using this cross-guide coupler, we want to measure an amplifier output power of perhaps 200 watts. Well, it's not going to do it as it stands. So what we have to do, we have to put an additional attenuator onto the output port that we're going to use. If that were a 10 dB pad, it would now change the total attenuation from 30.2 dB as shown on here to 40.2 dBm. The output of a 400 watt amplifier is 56 dBm. So now with our 40 dB here in total, and the fact that our power head can read up to 20 dB, we now have the ability to test a 400 watt amplifier on this particular setup. And of course, if we want to go over 400 watts, we've got to increase the attenuation on the output side of the cross-guide coupler. One of the nice points about this particular power meter is the fact that you can build in the offset, and so therefore the output that it shows is the actual output. You don't have to calculate it by adding or subtracting dBms to it. In this case, the offset is set at 40 dB, which is about the offset we've just been talking about. It's that cross-guide coupler at 30 dB plus the pad, and now this is set up immediately to start testing up to a 200 watt amplifier. And I could set it to anything necessary to support the cross-guide coupler. Don't forget, on one of those cross-guide coupler ports, it was 50 dBm. And so with this combination of the power meter and one of the cross-guide couplers that we've already selected, it makes it relatively easy to test an amplifier. And don't forget, we don't test an amplifier just at one frequency. We run the entire frequency range through the cross-guide coupler and the power meter, because not all amplifiers are linear between the bottom end and the top end, and so it's important to know where the peak output on an amplifier is, at what frequency it is, and all of this can be done relatively easily using a cross-guide coupler, a dummy load, and a power meter. Okay, I hope that is useful to you, and I'll see you on the next video.